Hello, statistics and pre-calculus. It's a bright sunny day, but it's a little bit chilly, so I've got my nice hat on. We're going to do today some translations of irrational functions. See, you've already dilated them. Let's translate them. Part 1, this first video, is going to be given an equation, draw a graph. Part 2, the next video, given a graph, write an equation. So here you go. Translations of rational functions. Here we have the function y equals 1 over x, and we are translating it. And by this equation, you see that it is translated 2 up and 1 to the right. So there you go. The first thing you want to do, thing number 1, draw your asymptotes. Your asymptotes were usually the x-axis and the y-axis. But now it's 1 to the right, so the y-axis has moved 1 to the right, your new asymptote. The x-axis has moved 2 up, your new asymptote. This one is not dilated, so just the points 1, 1 and negative 1, 1, negative 1, negative 1, based off of that original graph, go there. And we have our new graph. Those points, I went 1, 1 and negative 1, 1 from this point where the asymptotes meet, as if that was the origin. So we've got those, and so that's now 2, 3, and this one is 0, 1. The asymptote is y equals 2, and this one is x equals 1. This tells us our domain and range. The domain, x can't be 1. You can see that from the graph on the asymptote. You can also see it from the equation here, where if x was 1, the denominator would be 0. So the domain is x can't be 1. Also written as negative infinity up to 1 and 1 up to infinity. The range, y cannot be 2. Y is not 2. Written as negative infinity to 2 or 2 up to infinity. There you go, catch your breath. The next one we're going to do has a dilation also, but we can do it. All is good. 2 methods on this dilation one, however. Thing 1, this is example 1, page 428. What is going on? We have a dilation by 3. And remember, with these rational functions, the dilation is both directions. It's both vertically and horizontally because of the symmetry going on. It's all good, and we are still right 1, up 2. So, start with the asymptotes again. Up 2. The asymptote y equals 2. Right 1. The asymptote x equals 1. Now, we have a dilation by 3, and the way you'll take that into account is normally, instead of going 1, 1, you went, if it was 3, you're looking for numbers that multiply to 3. 3 and 1, 1 and 3. So we can go from our new origin, 3 and 1, 1 and 3. And here's this branch of the hyperbola. Likewise, from the origin, negative 3, 1, 2, 3, and negative 1, and negative 1, and 1, 2, 3. And we have those points. And there it is. This was 2, 5. This is 1, 2, 3, 4, 3. This one is negative 2, 1, and 0, negative 1 are the coordinates there. So that's the visual way of doing it. We can also do it by using your table, doing your favorite table task, table thang. We start with the original equation, which goes through the points. One, 1, and negative 1, negative 1. We dilate it first. It's dilated by 3 in this case. So dilated by 3, remember it goes both directions. This 1, 1 becomes 1, 3, and 3, 1. Goes both ways. Likewise, -1 becomes -1, -3, and -3, -1. And now we do our translations. Up to, so these points become up to 5, 3, -1, and 1. And to the right, 1. So this becomes 2, 4, 0, and -1. No, it moved to the right 1, -2. -2, 1, 0, -1, 4, 3, and 2, 5. Now your asymptotes are also the same points that we were talking about. It goes to the right 1, it goes up 2. Might have been more helpful to draw those ahead of time and then you see where those points fit in, but you see that we got the same points that second way. And here we have it. And again, the domain x is not 1, so -infinity to 1 and 1 to infinity. Y is not 2, so -infinity to 2, 2 to infinity. There we go. That is how to graph a rational function when you know that information, when you know the equation. Next video, given the equation, or given the graph, how do you write the equation? We are on it. See you in just a few moments. Okay.